This video is on modeling linear functions, and so we've talked a lot about lines. We've learned how to graph lines, we've learned how to find the slope of lines, we've learned how to write the equation of lines, and so now we're going to talk about how to model real data with a linear function. By a linear function is a line. So basically we're going to be writing the equation of a line from some data that they gave us. So here is the first example. It's about electricity use, and it reads like this. It says data on the average annual household use of electricity in kilowatt hours are listed in the following table. And so I've copied that down right here for us to use. It says model the data with a linear function and predict the average annual household electricity use in 2019. So this textbook is a little old, so we might just push it into the future, maybe 2022. But this is what we use with linear models. If we can say, hey, this is a pattern that this data is forming, and it's forming, it looks like it's linear. Maybe I could write an equation that matches that. Then I can predict in the future what's going to happen. So that's what the idea is here when we model with stuff, with mathematical models. So what got us off the hook here from doing a scatter plot and trying to decide what shape this looked at was when they said predict what's going to happen, use a linear model. They told us what to use. If they didn't say use a linear model, what we would have to do is plot these points. So we would have to draw a little XY axis and say, oh, in this year it was this much. And so what you see here is they gave you 2010 and they said, let's use that as the starting year. When you start taking data, that's the beginning. And so we say that's year 0. And then 2011 is 1 year later, that's year 1. This is called normalizing your data. And so when we do that, we will plug in these normalized value into our function, not the real year, this normalized value. So what we would have to do if they did not say use a linear model to predict this, we would have to plot this data. So maybe we had, let's pretend we had 10 data points. So maybe it looked like this. That is a crazy looking model, and that would be hard for me to say that that is linear in any way. If you plotted some data points and they looked like this, you might say that looks sort of like a parabola, not a linear function. Or if you had one that looks like this, you might say, oh, that's sort of fitting the pattern of a line. There's some outliers. We are going to be doing a little bit of that. Not much, but since they said model this with the linear model, we don't have to worry about that. What does the linear model look like? It looks like this. Y equals mx plus b. And we also know how to plug in, we also know the point slope form of a line to help us get there. So if they give us all this data and they say, write the equation of a line or write a linear model, they told us to do that. We're ready to go. All you need is the slope and a point. Now, when they give you points and they've told you use the write a linear model, you get to choose which points you want to use. So if you were in statistics and you were doing linear models there, you would form a scatter plot like I said. You might plot this and you say, oh, and you would use a method called least squares regression to find the best fit for these lines. But if you were just guessing, eyeballing it, you might just try to draw a line that hit most of the points. Then you would take 2 points and calculate the slope and write the equation of that line. We're just going to take any 2 of these points. That's what we're going to do. So if you and I choose 2 different points, then we might get 2 different lines, but they will be close to what they are. So close to each other. I'm just going to choose the first 2 points. We could choose any 2, but I'm going to choose the first 2 points. So my x value is 0 years, and my y value is 11,504 kilowatt hours. And my second point is 1,11,280. Okay, so m is the change in y over the change in x. Now I chose these because there was a 0 involved, and that makes your math easy. You wouldn't have to choose those 2, but that's what I decided. So y2 is going to be 11280 minus y1, 11504 over 1 minus 0. And so, let me get my calculator. 11,280 minus 11,504 is negative 224. Negative 224 over 1. The units on this is going to be kilowatt hour, kilowatt hour, kilowatt hour per year. So what this is saying is that the annual household use of electricity is going down, per household, is going down by 224 kilowatt hours per year. That's what that's saying. Okay, that's our slope, negative 224. Now we just pick a point. We need a point and a slope to write this. So I'm going to choose the first point. So right here, this is going to be my x1, y1. This is going to be this is my slope. So I say y minus 11504 is equal to the slope negative 224 times x minus x1, which is 0. Y minus 11504 is negative 224. X minus 0 is just x. To solve for y, I'm just going to add 11,504. Negative 224x plus 11504. This is my linear model. Now, sometimes I like to write it as f of x, a function of x. So that makes me think, what is x? It is the year. What is f of x? It's the amount of electricity use in that year. So let's answer the question. It says, if that is what's going on, it says predict the average annual household electricity use in 2019. Now that's already passed, but let's just use that anyway, and then we'll predict it in like 2022. That's what I said. Okay. So 2019. I am not going to put 2019 in here because I have normalized my data. What was the starting year? The starting year was 2010. So how many years have passed since this model started being used? 9 years have passed. So what I want to say, I'm going to take f of 9, which will be the amount of electricity use in 2019. Let's predict that using our model. That's going to be negative 224 times 9 plus 11504. Okay, so we're going to find that number. Let's go ahead and answer it. What if it said, what's the annual household use in 2022? All right, well then that is going to be f of, well, how many years have passed since 2010? Well, 12 years later. So we're going to plug in 12. So if this pattern continues, we can predict the amount of annual household electricity use in kilowatt hours for the average household in the year 2022. So let's just plug in the numbers. Let's see. Negative 224 times 9 is plus 11504. I got 9,488 kilowatt hours. Okay, if this pattern continues, what will it be? What will it be in 2020? So we'll say negative 224 times 12 plus 11504. We will have gone down to 8,816. If that pattern continues. So if we had to write a sentence, and they said, well, write a sentence explaining this. Let's explain this. If, according to the model, according to our linear model, and I'm saying this out loud because I know you can't read my writing. According to our linear model, the annual household use of electricity in 2022 will be 8,816 kilowatt hours. Okay, that is an example of linear modeling. I've got two other examples we're gonna be doing, but I'm gonna pause the video to give you guys a break, and we're gonna do the two other examples after this.